Hi, today we are talking about changing the seals on the high pressure fuel pump regulator. It's a Bosch fuel pump and it's on a Freelander TD4. It's located way down there. Why are we changing it? Because the measurement of the voltage on the high pressure fuel rail sensor, which is down here, shows that the voltage is too low at certain revs, which means the fuel pressure is too low, which means you might get poor atomization of the diesel fuel as it's injected into the engine, so it won't be running quite as well as it should do, and maybe it's a bit smoky. It's quite a common fault as the mileage goes up on these engines. The little nylon washer that's as part of the seal can wear, possibly the O-ring might split or also wear down, and as a result the fuel pressure lowers. So the fuel line sensor is down here where my finger is pointing, and the original, I've actually got a Synergy fuel mapping box on it at the moment, but the original connector is the blue and black wire down there that my probe is on. I've just peeled the insulation back, stuck a probe through the middle of the wires. The other end goes on the battery negative, and then the voltage readings that you should get is with ignition on, it's about half a volt. With engine idling, it's 1.28 volts, and with 3000 revs, according to somebody on the internet on a good engine, it should be 1.96 volts. So on this engine, it's only 1.41 volts. So that's a little bit indicative. If the voltage is not going up enough, it means the fuel pressure is not going up enough. So possibly it's a problem with the high pressure fuel pump or the regulator on the pressure pump, which is a bit of a known weakness. Apparently it's down there somewhere where those pink blobs are, the pump, and on the end of that is the regulator. You can just about see it if we pop in there. Yeah, I think that's, is that it? No, that's not it. Over, yeah, that thing there, that is apparently the regulator. And there's a known weakness on that where the O-ring can break or degrade, I believe. So it's worth checking that. I think taking this manifold off is going to be easier to get access to it. So now we've taken the inlet manifold off, we can get a better look in the regulator. A little bit easier to get to. So there's a plug on the end and two torque bolts, I think. So that is it, right in the middle of the screen there. A little bit tricky getting to those bolts, but I think the only way to do it is get a ratchet in. See the handle here, and there we go. There's with our Torx bit on the end, and then just about enough room to wiggle up and down to get the bolts out. So this is the high pressure regulator on the high pressure fuel pump. So you can see on the original set of seals that the lower nylon washer has got squashed, which means that the top rubber or Vitron or neoprene washer, whatever it is able to move down a fair bit, and possibly that will then twist like that and let by a bit of the high pressure diesel fuel. So it's just that lower washer is certainly worn out and could do with replacing. Hopefully that will improve the diesel pressure. Also to note, some people seem to report having a rubber washer in here. Mine didn't have it. I'm guessing that that's just to seal to the outside. I guess they're then just relying on this outer washer to seal it. I managed to find this little rubber O-ring in my set of O-rings, which is a useful thing to have. Check out my buying links in the video description for stuff you might need for this job. So we need to make sure everything's clean. It's not a disaster if you don't have it, I don't think, because this is just a method of double sealing. And also make sure that the valve fully seats home with this in place. You don't want it too thick. Here's my new set of seals. Cost under a tenner, under 10 UK pounds. With a Vitron seal, a little rubber O-ring type, not rubber but Vitron, and the nylon type washer. On the previous ones, these ones had a little split in them. It's there just the end of my screwdriver. You'll see if I pull it out, it opens up. That obviously aided refitting. To get the rubber O-ring off, just get a fairly blunt screwdriver like this electrician's one. Pull it over the O-ring, just poke it through, get that rubber to go over the lip of the end, and then you can pull it off like so. And I'm guessing it's going to be the same with this nylon washer. Persuade it to come off where that split is. Doesn't really matter if it breaks in two because we'll put a new one on. There we go. You see there's quite a significant thickness difference between the new and the old. Provided I can get it on, that new one should provide a tighter fit. Hopefully that's a good thing. And in fact the new nylon washer also has a split in it, as you can see there, to aid refitting, so that should be quite straightforward. Probably just a matter of pushing it over the end and gently opening it up, doing it evenly. And this last little lip is the critical bit. We'll just persuade it apart a little bit. I want to have it breaking. There we go. One bit down. Next we can just gently maneuver it around. Final bit of lip. Like so. There we go. Push that back together. Alright, hopefully that's good enough. And next with the new, they call it Viton, Viton seal. I'll have to look up what Viton's actually made of, but similarly just push that over the lip into place. Now I suspect we're going to have to put a little bit of diesel. I'm not sure about whether grease would be tolerable, probably not. So maybe a little bit of diesel on that to aid lubrication, to aid getting it in would be a good thing. Now that is the new one fitted. Noticeably it doesn't move up and down so much because there's not so much slack in it. Let's try and refit it. And not forgetting the flat washer as well, of course, fitted. Now that that nylon washer has been removed, you can see how badly it was distorted. Obviously the fuel pressure was getting through there, blasting through one little spot. So that's a good thing to replace. So when you refit a unit, which is just down there, see I've got one of the bolts in, it's useful to do it with a little magnetic end. These little magnetic pickup on extension bars are quite handy. There's the next screw to go in. You can then maneuver it into the hole for the bolt. Next one's there, without danger of dropping it. Because I would say be very careful not to drop stuff, because it gets lodged in between like the alternator and the air conditioning compressor. It's a bit of a job to get it out. I dropped one of my sockets down there, which took a while, but also extracted some other people's tools that they dropped down there previously. It is possible to do it without removing the starter motor, which is what I've done. Left the starter motor in place. Saves a little bit of time doing that. But to tighten up those bolts, you will need to have a right angle on your Torx key. Swap this to a wrench in a minute to give you in effect a right angle. Next we'll try and manipulate in the next bolt, which let's see if we can show you how we're going to do that. In and around at the side here, and then once we've got it through the hole, we can then get our fingers down there to tighten it up a little bit. So that's the magnetic bit released, and then you can get a hand in there. I think I'll have to do it from the top to get your fingers around that bolt just to tighten it up. So here's the wrench and attachment bits that we need. You'll see there just about enough space to get those bits onto the bolt and allow you to do it up. Might need to move some of those pipes, just push them up a little bit, but that's basically how you get in there. So that's it, all reassembled again. This time we'll measure the voltage on the high pressure fuel sensor. So we've got a meter over here. At idle it's 1.28 volts, so the big difference was at 3000 rpm. So this is with the engine warmed up. So if it up it to 3000, we've got around there, and now we've got around 2 volts. Let's get on 3000. yeah, around about 2 volts, which is what other people report that they're getting. So that means that the high pressure fuel pump must be working correctly, and the high pressure fuel pump regulator must be working correctly. So it was giving a low reading and therefore a low pressure, and due to that washer worn out. Before we go, just mention one other potential problem that's worth checking on, and that is on some cars you can sometimes get a bit of water in this plug that goes onto the high pressure fuel rail. The connector or the wiring can get corroded and disconnect, so it's worth checking that you've got correct resistance and voltages between the connector and where the connection goes into the ECU, which is in this covered box here. Undo the bolts. The connector you want is the third one from the right. It just does slide up pieces of plastic to release those pins. I don't think I've got a problem on mine now because I'm getting the correct voltages at the fuel pressure rail, but worth checking anyhow because it is a known fault, for which there is a kit for replacing the connector and the wires direct into the ECU connector. But here we're just going to check the resistances and the voltages. So we can test the resistance between the plug right at the ECU, which is pin 33, that one there, which connects to a blue and black wire, and it goes down to the beeping from the connectivity tester. So we're fully connected, and we're connecting the other end to the blue and black wire right at the terminal plug as it would go into the high pressure fuel rail sensor. I've got the Synergy mapping box connections here, but apart from that, that's what you'd have. With the Synergy box connected is the yellow wire, and if we turn off the switch on our Synergy box so the fuel is turned off, both the switches high, and that does indeed connect straight over to the yellow wire as well, which is the signal wire, and the other 2 wires that go to the fuel rail pressure sensor, because it's an electronic device, are regulated 5 volt. Fortunately, because I've got the Synergy box connected, the wires are a bit more accessible, so, and the colour codes for those are just red and black, so we've got near enough 5 volts on the red and ground or near enough onto the black, just to make sure the black is connected. We'd also do the resistance of it down to the ground connection as well, which is about 0.6 of an ohm, which is fine. Instead, you want to check the resistance rather than the voltages, then these are the pins you'll need to probe onto to check between these pins and the other 2 pins of the fuel rail pressure sensor. So that's it, that's all the problems to do with the fuel pressure rectified. And obviously if you've got the correct high pressure fuel pressure, then you know that the low pressure fuel pump and the low pressure fuel sensor must also be working okay. Hope that helps with yours. Thanks for watching. Bye.